Hey everybody. First, I just want to say thank you. This is the last time I'm going to talk to you in a pre-recorded lecture-y sort of situation. And the big headline of all of it is to tell you thanks. It's been quite a roller coaster. We've had a quarter like no other, right? Um, or except like no other except for spring and maybe this winter and hopefully not a lot after that. But here we are, fighting the pandemic, still trying to learn, everybody giving each other a little bit more grace and space and a chance to, just accept that things are going to go wrong and we're going to do our best to work together to fix them. So thank you for your patience. Thank you for your achievement and your learning. I have been super happy and pleased to see the strides that some of you have made and the enthusiasm that I've seen in a lot of people. Um, I know it's not easy learning during these circumstances. I know it would be easy to just kind of pass it off and go, I'm going to do the minimum and I'm going to get out of here, right? And hope for a better next quarter. But no, I've repeatedly seen people buckle down and use this time to really learn stuff. I've seen people work on some amazing projects. I've seen people, you know, ask for help, right? Like, that's a big deal for a lot of people. Like, actually admitting that I need to go to an instructor and specifically say, hey, I don't get this. That takes bravery and courage, and I appreciate each and every one of you who did it because what I get out of this is watching people grow, right? I mean, I get a paycheck, but the reason I do this job is to help you learn. So thank you to everybody who took this seriously, who managed to put on the blinders to ignore everything else going on this year and focus in on this topic. So you have a future. Maybe a future that includes a lot more machine learning classes. And I wanted to say a few words about where you might go, what you might think about in terms of your next steps with machine learning, artificial intelligence, whatever it is that you're interested in. Okay? I think you've got a strong sense at this point of the nature of both the practice of machine learning and the theory behind it. What you don't have a sense of is things that go on in industry that involve machine learning but are not of the kinds of things we've talked about, right? We we haven't talked at all about like these giant software pipelines and these data management techniques and things that people use to, in a business, apply machine learning, right? There's a whole set of skills that we haven't even hinted at out there that people who take these models that you and I have kind of played with this time and apply them to big data in real businesses and maintain these models that are used for decision making, right? They're used for the business in one way or another. And there's a whole set of skills involved in not just the creation of models, which at least you kind of have a sense of now, um, but the maintenance of them, the care and feeding of them, right? These models are continually sucking in new data moment to moment and being revised and updated, and they have to be continually available to the people that are using them. You can get a sense of it from what Google does, right? Like, that's probably the most familiar of these things, where you know that every moment of every day there are web crawlers out there figuring out what's on the internet and integrating those continuously into Google's algorithms so that when you search for porcupine hats that you find porcupine hats, whatever the hell those are. Right, so the world contains a lot more to machine learning than what we've talked about. So for those of you that have an industry focus, there's a whole set of skills out there involving big data, model management, continual model improvement, these kinds of skills that are completely infrastructure, really. They're making machine learning work for businesses. And I just wanted to mention that because I know in terms of, for those of you that might be thinking about careers and involve this, that kind of operations sort of stuff is in high demand right now. Now, whether that will be true when you graduate in 3 years, yeah, these things change quickly. But because I know that it hasn't even entered maybe your consciousness, I'm guessing if this is your first, highly theoretical course in machine learning, you won't have had the experience probably of knowing this is even a thing. Okay. What about other things in machine learning that we haven't talked about at all? Like different kinds of machine learning. Well, obviously there's an entire world out there of unsupervised machine learning that we haven't touched. And that is the subject of a different 118 course in cognitive science. So I can highly recommend taking a look at 118B for unsupervised learning. For thinking about things from a different perspective, there is probabilistic and Bayesian kinds of approaches that we haven't talked about at all. If you take a look at the Chris Bishop book, our nominal textbook, I suggest you give it a flip through, right? I know that maybe a lot of you didn't really look at it much during the quarter, and that's fine. We designed the course so that you can get all the information you need largely from what comes out of my mouth. But to be honest, Chris Bishop's book is worth your while, as is the other 2 books that I mentioned in the syllabus, Hasty Tibshirani, and I forget the third, the Elements of Statistical Learning, and the David Mackay book. Those 3 textbooks are worth your time. So the Chris Bishop book, to return to what I was saying a minute ago, is got an approach which is focused on Bayesian reasoning, okay? Looking at things from a probabilistic perspective using Bayesian theories. This is probably a major growth topic in machine learning. I mean, it really has been for a decade already, but it's clear that a lot of work is going into this, and it's nothing but a growth field, especially for those of you that are interested in interpretable models and models that have, a structure to them that you can understand what they're doing. Bayesian approaches to the classical statistical inference are a hot topic right now. Another aspect, like I said, is just to get into the statistical inference world. So frequentist statistics, sometimes you can call it the opposite of Bayes' rule, but it's actually not really the opposite. They're complementary. But classical inferential statistics, that's that Hasty and Tibshirani book that I've linked to in the syllabus, and it is the Bible. If you want to know, when I want to know something, I'm doing research in machine learning, I want to know something, I go to the Hasty and Tibshirani book. So the treatments there of machine learning are canonical, right? This is what, we understand as the right kinds of math to understand the situation in a lot of cases. Another book that I mentioned is the David Mackay book, which recasts machine learning completely as information theory. and looks at it from that standpoint. If you don't have any idea what information theory is, well, the Mackay book can give you a reasonable grounding in that. So as methods of self-study, or as ways to just like flip through them a little bit and understand how they approach the topics we did, just looking at the same topics like linear regression and support vectors and stuff like that in these books, and you will see how you can approach the same material from a very different direction. And having seen that, you will have a better understanding of machine learning. Okay, so stuff we haven't talked about at all. Reinforcement learning is a completely different world where it's based on the idea of the fact that instead of having a supervised, set of labels, that you just get a signal now and again that, oh, you did a good job. No, you didn't do a good job, right? And it's not delivered all the time. It's not a label. It's just, at the end of the day, good job, mate. There you go. And it's your job as a learning algorithm to figure out what of the 10,000 things you did during the day got you that good job. So reinforcement learning is also an expanding topic of machine learning. And buzzword deep learning and buzzword reinforcement learning are starting to come together in new and wondrous ways. Maybe you've seen some headlines recently about the AlphaGo program, which can suddenly solve some very amazing problems in predicting how proteins fold. If you want to make $1 gazillion in biology, understanding how proteins fold is a very, very important topic. And for the first time, some of these problems have been marked as solved by this reinforcement learning deep learning network called AlphaGo. All right. So check into that stuff. Read around. See what's out there. There are many courses at UCSD. I think you may have a better handle on what you want to do. So I'm not going to natter on about things. I'm not going to tell you what's out there because you probably know the course catalog better than I do. But these courses come in all kinds of different departments, right? So the HDSI, computer science, and electrical and computer engineering are just a few of the things. They're offered in math and in economics and, all over the map. So take a look around, see what's exciting to you. Because there's a lot of different ways for your journey in machine learning to unfold. You can, kind of go the implementation route and, get yourself trained up in it and get a job doing it. You can go the infrastructure route that I preceded earlier, become a big hardcore computer scientist, DevOps kind of person who works in the field of maintaining machine learning stuff. You can become a theorist, get good at math. Actually, I was just for my other class reading the Anaconda, like the Python distribution, Anaconda distributions data science report for 2020. They were surveying companies and graduating students and looking at what do graduating students have that, listed in their most common skills and what do companies want. And, for the most part, those overlapped. But the two things that, companies wanted was big data management, that kind of, infrastructure stuff that I was talking about, and advanced mathematics, right? And the students, those were the two things that the companies wanted that the students didn't have, okay? So, if you want to become a theorist or you want to become an infrastructure person, right now, that's the big demand that's not being fulfilled at this very moment, or at least that seems to be true according to one survey, okay? Yeah, so exciting times. There's a lot of possible paths. And even if this is the end of your machine learning journey, that's cool too. there's a lot of room for self-study and growth uh, outside of the university environment. So you've got quite a lot ahead of you, and there's a lot of resources out there to help you get there. So I want to say to you, good luck. I, like I said, I get so much pleasure out of watching you develop and learn and grow. I hope that you will check back with us soon, right? I want to hear from you as you navigate the other machine learning courses, and I want to hear from you guys what was great, what was bad, so I can know what to tell future quarters of this class. I would love to hear from you in 2, 3, 5 years about how your first jobs go and where you all end up. Please keep in contact. I would like to hear from you right now, this very week, before the 14th. If you have not filled out the teaching evaluations, the CAPE forms, please do so. Your feedback on this course is super important, both to my career, because I need to hear what you need, and that's going to develop me to be, in the end, ascend to the upper echelons of professordom. No, I want to get tenure and teach more of you guys, okay? And to do that, I need feedback. I need to know where this course failed. I need to know what this course did well. I need to know the elements of my teaching style that worked for you and the ones that didn't. So I really, really, really want you to check in with the CAPE form, and please give feedback for both myself and the TAs. Speaking of which, I know that I can say on behalf of Aparna and Juhai that they also really enjoyed helping you all achieve over the course of this quarter. The questions on, projects, the learning that you've all displayed. It's a lot of work to put on a course like this, and it's those moments that make it worth it for us. So I hope that this has been worth it for you. I sincerely hope that you feel that we gave you something of value, right? Even in the midst of all this crazy pandemic nonsense. Yeah, and I just want to say how thankful I am that you've continued on and journeyed with us through all this. So I wish you the very best of luck. If there's anything else that we can help you out with as you navigate your future, please reach out, okay? And please check back in with me in the future. I do want to hear how things go for you. All right, everyone. It's been a real pleasure. Good luck. Asta.